Hello everyone, my name is Michael Kagan and today I'm going to be talking about a world of augmented reality. So I really started to develop a love for a world of augmented reality this past summer as many technological advancements in gaming and leisure started to be produced. Obviously there's several smartphone games and we're going to discuss most of them in these presentations, but there was also the feature of other countries' advancements in these areas, in particular just a real life applicability for leisure, entertainment, and fun. And so I'm going to talk a bit today not just about the real world aspects, but also the technology behind how is augmented reality actually utilized. So a little bit of a breakdown of how this presentation is going to go. We're going to talk about what is augmented reality, how is it implemented, the current examples or models that are on the market, the pros and cons of using augmented reality, and finally, the conclusion. So to start off, what is augmented reality? I think a very well-rounded definition for augmented reality would be an enhanced version of reality created by the use of technology to overlay digital information on an image of something being viewed through a device, such as a smartphone camera. It is conventional in real time and also semantic in context. So what does this mean? Augmented reality allows a user the ability to channel technology into real-life situations. Technology and real life are always separate. But what if, in real time, data or leisurely content or gaming was channeled and mixed into our everyday lives? And I believe that's the ultimate goal of augmented reality, is to blend the two worlds together, the technological and the real world. In fact, as early as the 1990s, as part of the U.S. Air Force's Armstrong Lab, this is some of the earliest records that we can find of augmented reality being used. So if you look on the bottom right-hand side, you'll notice a photo of an Army soldier who's actually testing some of the earliest prototypes of augmented reality systems. So how is it currently implemented? Augmented reality consists of four main hardware components: the processor, the display, the sensor, and input devices. So I'm going to break down each of these individually now throughout this presentation. The processor is typically used on mobile devices and includes microelectromechanical systems. So today, as augmented reality is produced, the easiest way for it to catch on with the public is to use devices that currently can implement that technology. So for instance, smartphones and tablets have already begun to roll out this technology. In regard to microelectromechanical systems, so for those of you who don't know, this is a technology of microscope devices, and it actually incorporates nanotechnology. Now onto the display. The display incorporates optical projection systems, monitors, handheld devices, and display systems. The idea behind this is that you can use technology, or wearable technology even, to bring that augmented reality into the real world. And one example of this is a head-mounted display. For those of you who are familiar maybe with Google Glass, or even if you look in the bottom right-hand corner of the screen, you'll see an example of a head-mounted display. So this technology is meant to present data without having to look away from viewpoints. Augmented reality occurs using retinal sensors, and what it does is rather than steer away your general course of vision, while merely navigating in your general sense of direction, you're having this technology become a part of the real world. And that's the ingenuity behind this technology. It's not meant to be a distraction, but brought into your everyday routine. Now let's move on to sensors. So sensors can incorporate a number of different technologies and also different metrics. First, we have obviously the digital cameras. You have optical sensors, as we discussed before with the head-mount displays. Sensors also incorporate some calculations such as accelerometers. Accelerometers actually measure proper acceleration relative to gravity. There's, of course, the guidance positioning system, gyroscopes, solid-state compasses, and RFID. RFID stands for radio frequency identification and actually uses electromagnetic fields to identify tags attached to objects. Then, of course, we have the input devices. So input devices use speech recognition systems that translate spoken word into computer instruction. These gesture recognitions interpret users' body movement by visual detection or sensors. In other words, using speech and movement to interpret what will happen with this augmented reality. So after doing careful research online, I believe I found a very successful starter kit that helps us to understand from a computer science standpoint how we can develop our own augmented reality. And so Floor Toolkit was a kit that you can download with zip folders online. And using some of these code segments that you can see here at the bottom, I can help to illustrate the photos above. So on the left-hand side, I'm going to talk a little bit about what's being implemented in this code. So first we load markers into an array so that they can be easily called on. And as you'll notice when the markers in the array, each one gets an id. So we start off with an id of 0, then an id of 1, and so on. And then after that, the code to the right deals with the manipulation of individual cubes. So in this code, the z-axis of the cubes is altered, and each cube is designated as its own object. The variable cube has all the information for cube rendering, and the materials list, as you'll see in the code, refers to the outside of the cube. We want each side of the cube to look exactly the same, and so the material is stored in a variable and will be used in the code. If you look in the code as well, you'll see the 340s, and these represent the dimensions of the cube. This represents, of course, the length, the width, and the height. Now, looking at the photos from above, let's take these code segments and see what this produces. So on the left-hand side, with the markers as we discussed before, you'll notice that an augmented reality has been generated, where 4 cubes are produced and are seen floating on top of a piece of real-life paper. However, on the right-hand side, as we defined the actual material of the cube and the specifications, you'll notice that as you move the paper, it also shifts the actual position and the free fall of the cubes, something we talked about before with the makeup and components of what augmented reality is. So now let's talk about current examples. If I'm going to talk about current examples, I think I have to talk about the most popular example of augmented reality, which was, of course, Pokemon Go, an augmented reality game that was released in the summer through Niantic and Google. So the idea behind Pokemon Go was, first off, it took the world by storm in 2016, and the idea was that you could travel, you could go anywhere you wanted to, and non-dependent on where you were, you could catch Pokemon, you could use famous landmarks to accumulate items, you could also go to gym and accumulate badges, and really brought that real-world sense of what Pokemon games never had, the idea that you could be a trainer and experience the game for real. Pokemon Go also utilized Microsoft's HoloLens technology. This technology was very unique in the augmented reality world because what this does is it not only develops the reality, but it also allows the gathering of data and analytics. So as a user uses the technology more, it actually helps to gather important data that can be used to develop new and innovative ideas. And what's very unique that Pokemon Go got correct was that it utilized location services to seamlessly blend into an exciting gaming experience. So if you look at the game when you navigate, you're not just using a map of a built-in game. The location services themselves use your real-life location to determine what will happen. And that's something very unique to this experience, is that the game itself is reflective of your real-life experience, situation, and location. So let's go now into the pros and cons of augmented reality. So the pros. Experience with leisure. Of course, the beauty of augmented reality is it brings the gaming into you. So what does that mean? You can sit on the couch, and augmented reality can help you produce scores while you're watching that real-life TV game. Maybe you're watching your favorite sports, and all of a sudden, all the important data that you want is right there in front of you in your general view. There's also training and planning. So as we discussed before, when it comes to the Army, augmented reality is a great way to test real-time situations so that you can get necessary data about how you'll perform in the field. And obviously the feedback. So as someone is performing with a system that implements augmented reality, data is gathered and can help to be used to produce better and more innovative ideas. However, there are cons as well. Number one is the privacy issues. As we discussed with the HoloLens technology, the con is, of course, that as users continue to use this technology, much of their private information is not secure. This was actually a big scandal with Pokemon Go in the past, in that users were using their Gmail accounts, and much of their public information in regards to signing into Google, maybe they kept any bank information on there, was easily accessible to anyone who would hack Niantic. And then from there, there's also the lack of real world interactions. And this has been common with the development of social media and other technological innovations, is that as we continue to progress technologically, we do lose the societal aspect of human connection and interaction and really becoming close with others. And that's something that could suffer with the continued development of augmented reality. So in conclusion, augmented reality is a new and exciting realm of technology. Its scope of usage can be enhanced with some practical real-life improvements. As these two realities mix, the potential for change is truly unknown. As someone who's really become interested in augmented reality, I can only hope that it will continue to develop because there really are genuine applications to using this technology. I don't believe that it should be used in a way where we become lazy and don't move and really lose that sense of human interaction and just human movement of experiencing the world. But there definitely are practical uses, and there are ways to really change the experience of real life by bringing in that technology to whether it's sports, whether it's movies, whether it's a comedy, whether it's gaming. These are all definitely ways where you can enhance the human experience by bringing technology into your real life. These are my sources.